Hey guys, I guess this is part two of the video that I was making. I ran out of time there. But anyways, what I was going to say was that there's another way to do example number one. And example number one is the same exact problem that I was working on right here. Okay, 12x to the fifth plus 8x to the fourth minus 6x to the 3. So I think the book sort of does this. And then they do prime factorization tree. Okay, and so this tree, I'm pretty sure you guys have seen it before. So the way it works, two numbers that multiply together to give you 12, that's 6 times 2. Two numbers that multiply together to give you 6, that's 3 times 2. Likewise for the 8, two numbers that multiply together to give you 8 is 4 times 2. And then two numbers that multiply together to give you 4, that's 2 times 2. Two numbers that multiply together to give you 6, that's 3 times 2. And then you basically, all right, list the factors of 12, 8, and 6, right? So if I were to go ahead and do 12, right, write all its numbers, right? 2, 2, or, well, actually 2. I don't want to go ahead and use listing because I'm not really listing numbers anymore. I'm multiplying, right? 2 times 3 will give you, come on, times 3 will give you 12. 2 times 2 times 2 will give you 8. And 2 times 3 will give you 6, right? So you're putting, right, the list for each number where it goes. And then I think the book does this. They go, okay, well, you know what? Numbers that are in common, it would be 2, and really, there's not another 2 over here, so that's it. So the greatest common factor has to be a 2, and then really you just have to make sure that you can see, right? You're looking at your variables, which variable has the least, the lowest exponent, which would be x to the power of 3. So you just put x to the power of 3. Later, I do want you guys to not really even do all of this, just go directly from this all the way to this, okay? But bottom line is you still get greatest common factor is 2x to the power of 3, which is what we got on example number 1, okay? So you guys can do it whichever way you guys want. I really don't care. Number 2, so example number 2, I'm going to do the same exact problem that we did right here, which was negative 12x cubed. So negative 12x cubed, and then let's see, what else did I have? Plus 18x squared minus 27x. Don't make sure that that's what I got. Yeah, plus 18x squared minus 27x. So again, you can do this the same exact way as what I showed you right here. You can make your tree for each one. So let's see, I'm gonna make a tree for the 12. I'm gonna make a tree for the. I'm gonna make a tree for the 18. I'm gonna make a tree for the 27. Right. So for the 12, 6 times 2, 3 times 2. 18 would be 9 times 2, and 3 times 3 is 9. 27 is 9 times 3, and 3 times 3 is 9. So if I go ahead and I list all the factors of 12, factors of 18, factors of 27. So 12 would be 2 times 2 times 3. Factors of 18 would be 2 times 3 times 3. Factors of 27 would be 3 times 3 times 3. Then I can go ahead and, right, I can go ahead and I get, looks like this one doesn't have a 2, right? None of these have 2, so really can't be a 2 in there. But I can take out a 3, right? So we can take out 1, 3. So the greatest common factor will have a 3. And then you can use that one trick I showed you for the video. And so if you use that trick, right, this variable will have a invisible, right, implied exponent of 1. So you take the variable, right, out of the 3 variables, the variable with the lowest exponent, and you put it right there. So your greatest common factor is 3x for this polynomial. And if we go back up here, right, remember, if we did sort of like, I guess you can call it the listing method, right? We still got 3x for the greatest common factor. And if you're more comfortable and you feel like you can figure out the the multiples of stuff of numbers with the prime factorization tree, then go ahead and do that. It's completely up to you guys. I really don't care what you use. But what I do want you to know is that there really is actually there's multiple ways, as you guys know in math, to do stuff. But I'm showing you sort of like the listing method. So I guess I could let me grab. So I guess if I just go ahead and I kind of script this way, these two. So example 1 and 2, these are called the listing method, and my preferred method, to be honest. And then like example 1, and so I did example 1 and 2 again, but I did them with the prime. So we got listing method and prime factorization tree method. Whatever you guys want to use, I don't care. Okay. All right. So we got those two methods that show you how to do 1 and 2, listing method, 1 and 2, prime factorization method. The book uses this, but just so you guys know, don't really care what you use, like I said. So now let's go to let me give you two good examples. So different ones. So example 3. Okay. So I'm going to say factor out the polynomial. I want this polynomial to be the polynomial 1x cubed plus 5x squared minus 22x to the power 1. So for this one, guys, we want to figure out our greatest common factor, right? So I guess you could do steps if you want to. All right, steps number 2. Find the greatest common factor for numbers, and for the B for the variables. Okay, and we just kind of put them together, really. So greatest common factor for numbers. So let's do the first number. Okay, we got number 1, 5, negative 22. So I'll do number 1. Okay, so the numbers for the factors for 1 is literally just 1. The factors for 5 would be literally just 1 and 5. Nothing else goes into 5. And the factors for 22 would be 1, 2. What else? No. Sorry, the factors for factors for 22 would be 1, 2. 4 doesn't go into it. 5, no. 6, no. 7, no. 8, no. 9, no. 10, no. 11 does. And 11 and 22. Right. So then, if we look at this, our factors between 1. Sorry, I'm going to use a different color. Between 1, 5, and 22. Really, there's no numbers here, so really our greatest common factor for numbers is 1, and our greatest common factor for the variables, right? You look at the variable that has the lowest exponent, and that's 1. So x to the power 1. So you put them together, right? And your greatest common factor for the whole entire thing is 1x squared. 1 to the power of 1 times x to the power of 1, which is translates to the greatest common factor. Okay, is literally just x, right? That's really what it is. Okay, so that's example 3. Hopefully that makes sense, guys. You kind of take it step by step, and yeah. So now let's do example number 4. Feel free, you guys pause this whenever you guys are working this. I'm sure you guys can pause it. So let's do example 4. So example 4 is negative 16y to the power of 6 plus 28y to the power of 4 minus 20y to the power of 3. Okay? So if I go ahead and do this, again, you can do steps if you want to, right? So steps. I'll do this with a different color now. Let's go ahead and do a cool color like pink, I think. So step number 1, right? So find the greatest common factor, really. Find the greatest common factor, right? So you have to do it for the numbers, and again, you have to do it for the variables, right? So if we do it for the numbers, you want to go ahead and take 16. You want to go ahead and take 28. And you want to go ahead and take 20. Okay, so you want to go ahead and list the factors for 16, 28, and 20. So if we do this, factors for 16 are 1, 2, 4, 8, and 16. Factors for 28 are 1, 2, 4, 8, 14, and 28. Factors for 20 are 1, 2, 4, 10, and 20. And then you look for the numbers. So this is a common factor. The 2 is also a common factor. The 4 is also a common factor. What else? Is there a bigger one? Nope, that's it. Looks like the 4 is going to be the bigger one. Okay, so that means that the greatest common factor for the numbers, right, is 4. And then the greatest common factor for the variables, this one's the super easy one, right? You just take up the variable that has the lowest exponent, right, which is y to the power of 3. So, right, you put together, again, I'm going to do a really cool color. This one would be cool, I think. So you put together this, and then they sort of spit out the greatest common factor for the polynomial is 4y to the power of 3. You put these two together, right? 4y to the power of 3. So it's really 4 times y to the power of 3. Hopefully that makes sense, guys. So that's the greatest common factor. So now, let's go ahead and what do I want to do now? I want to do, okay, so so let's review a little bit about what we have so far. 13 minutes. So I think I'm going to keep it like this in terms of figuring out what the heck is the greatest common factor, and then I'm going to create another video on factoring out. Okay. So yeah, I think it would be really wise for me to create another video. So, but if I need more time, then I'll use it. Anyways, okay, so let's go ahead and do this one. Okay, so example 4. So now I'm going to tell you, okay, now, so you know what the greatest common factor is, right? Greatest common factor. And then I'm going to ask you, okay, factor out the polynomial. Okay, and that's going to have to be for the next video.